am going to present a presentation on the project Smart Factory IoT Monitoring System. Uh, Let us see the tables of contents: introduction, problem statement, proposed solution, system architecture, block diagram, working principle, result, advantages, disadvantage, future scope, and conclusion. Introduction: Internet of Things enables physical device to collect and exchange data over internet without human intervention. In industry environment, real-time monitoring of the parameters such as temperature and humidity is essential for ensuring the safety and efficiency and reliability. However, the traditional system often lack in automation and remote access and timely alert mechanism. This project presents a smart factory IoT based monitoring and control system that integrates sensor and Arduino based nodes and a cloud platform like ThingsBoard to enable the real time data monitoring and automated control and remote management. Then the problem statement: industry system lacks in real-time monitoring and automated control of the critical parameter like temperature, humidity. This leads to the delayed response and safety risk and efficient operation due to the absence of remote monitoring alert mechanism. So the proposed solution is a smart factory IoT system that uses Arduino based nodes and sensors to monitor the environment parameter in real time. The data is transmitted to cloud using MQTT and visualized on ThingsBoard dashboard. The system that enables automated control of the devices like ventilation through relay modules and support the remote monitoring and control using RPC, which improves the efficiency and safety. This is the system architecture. It consists of sensor, Arduino board, Things board, and a dashboard. We are using the sensors to collect the data and transfer it to Arduino, and from Arduino we are integrating an Ethernet shield to Arduino so that it helps us to connect to the internet, because Arduino board does not have any Wi-Fi or Bluetooth connections. From the using Ethernet shield, we are connecting to the internet cloud where data is transferred to the Things board. Then it is displayed on the dashboard. Let us see the block diagram. In block diagram, there are two types. There are two nodes, which is node 1 is called as a production line, and node 2 is called as warehouse line. In production line, which is called as node 1, it consists of three sensors which is integrated to Arduino: DHT22 sensor, which helps in uh, which helps to collect temperature and humidity for every 5 second, LM35, which helps to read the analog value of the sensor, to compute the temperature, and a vibration sensor. These three are integrated with Arduino. Then Arduino is integrated with Ethernet, which helps to connect to the internet cloud. Then from the cloud, then the data is pushed to the Things board, which is displayed on the Node 1 dashboard. Next, Node 2, which is also called as warehouse. It consists of three sensor: DHT22 sensor, PIR sensor, and LDR sensor. Uh, LDR sensor, which are integrated with Arduino, where Arduino is integrated with Ethernet to connect to the internet. From the internet cloud, it data is pushed to ThingsBoard and displayed on the Node 2 dashboard. Working principle: the system works by continuously collecting data from the sensors such as temperature, humidity, motion, and light using an Arduino based nodes. Then it is collected. Data is processed and sent to the ThingsBoard cloud through an Ethernet module using MQTT protocol. The cloud platform displays the data on the dashboard for real-time monitoring based on predefined conditions such as high humidity, system automatic control, actuators like relay to perform an action such as turning on the ventilation. Additionally, user can remotely control the system through RPC command from the dashboard. Result: real-time sensor data is successfully monitored on ThingsBoard dashboard, where like temperature, LDR value, humidity, LM35 sensors value, vibration sensor value are monitored on the ThingsBoard platform. Automated relay control is achieved based on humidity threshold. Means we are automatically controlling the relay based on the humidity threshold. Reliable MQTT communication is established between nodes 1 and cloud platform. Uh, the connection between node 1 and node 2 are established using MQTT between cloud and node. Remote control of the device is implemented using RPC. System is operated accurately and responded to environment changes in the real time. Uh, Advantages: real time monitoring of the industry parameters. The temperature, humidity, LDR value are monitored at the real time without being there. Automated control of the devices. There is automatic control over the devices such as relay and ventilation. There is a remote access using the cloud dashboard. We can control it remotely using an cloud dashboard. It improves the safety and efficiency where if the temperature value is high or the humidity is higher, then it automatically sends an alarm which helps us to which provides a safety and ensures the person safety. It is scalable and flexible in the system design. We can implement more sensor to this or add more lines to this so that we can it is a flexible system design and a scalable design. Disadvantage: mainly depends on the internet connectivity. If there is no internet connectivity, the whole system fails. Initial setup cost of the for the hardware, it requires initial setup cost which makes it costlier, so that it requires some hardware for the implementation. And it requires the basic knowledge of IoT and networking, which a technical person should have a knowledge of IoT and networking to set up this. There may be a sensor error which may be leads to the possible sensor inaccuracy. In security concerns, it may be security concern may be provided if it is not properly configured. Next, future scope. In future we can integrate, presently we are doing using a website we have developed for the website. In future we can integrate it with the mobile application for the remote control. uh, AI based predictive maintenance for early fault detection. Presently AI is booming everywhere. Integrating AI in this project makes it early fault detection. Wireless communication for scalability, and we can use Wi-Fi or LoRa for the wireless communication. Energy efficient automation and optimization. It helps in to minimize the consumption of energy by automation and optimization. Conclusion: the smart factory IoT system successfully demonstrates the real-time monitoring and automated control of the industry parameter using Arduino and cloud integration. This system efficiently collects the sensor data and transmits it to the ThingsBoard platform and enables both automatic and remote control of the devices through the relay and the RPC mechanism. This project improves the efficiency and responsiveness in the industry environment, highlighting the potential of the IoT in the modern automation systems. uh, Here my presentation is finished. Now we will see the online simulation of this project, which is implemented using a Pixim lab and ThingsBoard platform. This is the Arduino board in the Pixim lab. Using this we have integrated some sensors to this, where such as LM35 is connected to the A1 of the analog pin, connected to the analog pin A1, and the temperature sensor is connected to the digital pin 2. And here we are using a potentiometer in place of vibration sensor, which is not present in this software. It is connected to the A0, and we are using a push button which acts as a machine control. It is connected to the digital pin 3. and we are using an Ethernet which is connected to the which consists of MISO and MOSI, which where MISO is connected to the 12th pin, MISO is connected to the 11th pin, and reset pin is connected to the reset pin, and there are three LEDs where there are three LEDs which indicates three LEDs with the color green, yellow, and red. Green LED suggests that it is normal. Yellow LED suggests that there is a something warning or sensor error. Red LED ensures that there is a critical situation or it is disconnected. Then there is another LED, red LED, which acts as an relay status, and there is a virtual term for monitoring the data where it is where connection is established between MQTT or not. We can see through this. See, these are the data which is transferred to the MQTT cloud. Let us see the dashboard of this. It is actually a this complete connections is of the node 1 dashboard. Here is the complete dashboard of the node 1, which is called as production line. Here I have given the name as production line monitor. It consists of temperature, humidity, and a time series table where real time data is monitored here. And then a machine status LED which indicates that it is on or off, and a switch control which helps us to switch on or switch off the system, and sensor error is LED is present. If there is any problem in the any connection problem or any issue there is then this LED will be on, and a relay state is present here, and a time series chart for temperature and a vibration is given here. If I vary the now let us vary the temperature and the let us vary the temperature and the humidity here so that it will be present on my dashboard. Now see here temperature is not this, sorry. See here, I have kept a temperature near to 7 degree or 8 degree, and it is a humidity which is kept at 84%, and vibration is kept at 2.2 and LM35. This all data will be present on my dashboard. See, the temperature is kept at 7 and the humidity is 64, and sorry, 1 minute. See, now the temperature is kept at 1 degree, and humidity is kept at 64. Sorry, it takes a delay. There is a 5-second delay. The temperature is kept at 25 degree. Humidity is kept at 52 percentage, and the machine status is on here, and a relay state is on here, and a sensor error is not present. Now let us make an sensor error here. If I now if I change the pin number here, it shows that it is being disconnected. One thing, it is showing disconnected and red LED is on here. properties. Again I will change here. It takes time, few minutes time. See, you can see that MQTT is failed to connect here, which is displayed on the dashboard. Uh, Displayed on the virtual term. Again, it is showing that MQTT is failed to connect. There is some issue, I think, here. Wait. Sorry, I have not changed the pin here. Now it is being changed. I think now it may be connected. Sorry. Wait. Okay. I'll open my Pixim Lab once again. Now see it is been on, but here request timeout is being done. Now if we turn on the switch control here, it then the relay status will be on here. It takes time because the connection between cloud and the platform is taking time. See, there is a now it is being connected. If there is a disconnection, there will be MQTT fail. If I change this property, see that now I am changing a pin configuration of this. Okay. Properties. I am changing the pin configuration of this. Now it is connected to A no A1. I will connect it to A no A2. The data will be not present on the ThingsBoard platform because of this because it should be connected to A1 only. Okay, now let us see the node 2 dashboard. Node 2, this is node 2, where it consists of same temperature sensor, which is a DHT22 sensor, a PIR sensor. PIR sensor is an passive infrared. PIR sensor is an passive infrared motion sensor which helps to detect a motion present in the warehouse or not, and it consists of LDR sensor and an door switch, and it consists of three LEDs same, and it consists of a ventilation relay which is triggered when the humidity is higher. When the humidity crosses more than 84%, then it automatically triggers the ventilation relay, and it consists of same virtual term which is used to monitor the data, and it also consists of Ethernet. Now in dashboard there are three dashboard created here. One is production line, which you have been seen now, and a warehouse monitor and a smart factory. Production line is for node 1 production, and warehouse monitor is for node 2. It also consists of temperature, humidity, and LDR sensor is present here. If the LDR is more, then it is updated here. Then door status is here, is dark, motion detected, and a sensor error LED is present here. It also consists of time series chart, and it consists of a time series table for real time monitoring of data. And there is an alarm also here, and there is a switch control also present here. Then in if the temperature rises here, uh, temperature is raised here, then it gives the alarm status also here. Wait, I will show you how the temperature. I will show you. See, I have kept it for 96%. It will be it ventilation relay is on here. One thing. Second, it will be present. It Here it is present here. Second, then it gives an alarm that is that humidity is higher and it is a critical in severity. Then if the LDR value is higher, then it will be updated here. 2 minutes. Two LDR value is updated here, and the and is dark is on. If I reduce the LDR value, and door switch is off here, door switch is door status is on there, door status is on, and the LDR value is lower, so that is dark is off, and the motion detected can be enabled by pressing this PIR sensor for 10 seconds. See, motion detector is on here, and the sensor LED is present, and the time series chart can be varied by when I vary the uh, when I vary this, then it will be showing here. Sorry, it is not moved to the end. If I move to the end, see here, it is showing here. uh, this is the node to implementation of the dashboard, and it consists of a smart factory. This can be monitored by an line in charge, and the production line by the second line in charge, who is under the warehouse monitor line in charge. And overall, a person head can monitor this in the smart factory dashboard, where it consists of data from the warehouse and the production line. If I make the changes in the warehouse, if the data changes or the data is present on node 1 or node 2, then these data are being updated here. Actually, you can see here, when I made the changes at the there they, then these values are also being updated here. This was the presentation of the project on the smart factory with the online simulation. uh, I have learned many things, how to use the Pixin lab, and how to connect to the ThingsBoard, how to access the ThingsBoard platform. Actually, I was not knowing about this. This all has been I have learned while doing an online internship under MXC. This was my project presentation. Thank you.